Welcome to FlowDoodle. In this tutorial, we'll guide you through creating a simple process flow using FlowDoodle. We'll cover each section of the interface, explain how it works, and demonstrate its purpose step by step. Step 1. Initial setup, substrate and wafer. Let's begin by setting up the base of our process, the wafer. There are several start materials to choose from. For this example, we'll use a basic substrate. In the Attributes panel, you can see two sets of attributes. The visual attributes control the appearance of the structure on the screen and in the final presentation. The export attributes add important process information to the slides. Let's adjust the substrate visual thickness and add an export attribute to indicate this wafer has an orientation of 110. We can also visualize stress as it develops over the process flow. Stress will introduce curvature and can be positive or negative. For now, we'll keep it flat and uncurved. Step 2. Deposit a new layer, silicon nitride. You will notice that the different processes are arranged into logical menus. The Add menu shows additive processes such as deposition and plating. Similarly, the Remove menu shows processes that etch or remove material from the wafer such as DRIE, grind, and CMP. Now, let's deposit a new layer. We'll choose silicon nitride. In future tutorials, we will show you how to use the material editor to add additional materials and change their appearance. Once deposition is selected, change the thickness to 10 pixels. Add a few export instructions for the process engineers. Material, silicone-rich nitride. Process, PECVD. Thickness, 200 nanometers. You can add as many attributes as you need, including custom ones. Simply type the attribute name and value. Let's enter, for example, the expected refractive index of 2.2. Step 3. Apply photoresist. Now let's pattern this layer. We will use photolithography for that. First, we spin coat a photoresist layer. Step 4. Define a mask. Click Add Mask and name it appropriately. For instance, Scene Opening. This mask defines the region to be exposed or protected during etching. To pattern the photoresist, add a Mask and Develop process from the Litho menu and select the mask to use for patterning. Step 5. Etch the silicon nitride. Choose a dry etch step. From the attributes, select silicon nitride preset as the target material. Adjust the etch depth. Notice the etch rate selectivity table. You can modify these to best illustrate the selectivity of your process. If we increase the etch rate of photoresist, you will notice more photoresist is consumed during the etching. Step 6. Implantation. Now, let's add an implantation step into the silicone. Select boron as the dopant. Set the start and end depth. As with most processes, you may also select to implant the top and or bottom surfaces. Step 7. Resist strip and oxidation. Next, remove the remaining photoresist using resist strip. Step 8. Thermal oxidation. Apply oxidation to grow an oxide layer from the underlying silicon. Select silicone as the source material. Set oxide thickness, e.g. 20 pixels. Define the oxidation ratio. The default of 0.44 means 44% of the new layer penetrates into the silicone and 56% grows out into the air. Note: FlowDoodle also allows you to choose any ratio. This may not be physically accurate, but could be useful for illustrative purposes. You can click the bird's beak option to illustrate the displacement of the nitride due to the underlying swelling of the silicone as it oxidizes. Step 8. Isotropic etch. Let's repeat the photolithography process to define via in the nitride. Define the via mask, then apply photoresist and define it with the mask and develop steps. Perform an isotropic etch on the silicon nitride. This etches uniformly in all directions and can result in undercuts. Adjust the etch amount to control the undercut. Be cautious. Too much will eat away the structure. After the etch, don't forget to strip the remaining photoresist. Step 9. Add metal layer, aluminum. Add a new layer of aluminum. Use lithography again to selectively remove some of the aluminum and leave only the metal pads. Remember to change the polarity of the mask. Repeat the isotropic etch to leave metal pads. Note that you can always change any of the masks and see how the structure is updated in real time. Finish your process by adding a final resist strip. Congratulations! You've now built a complete process flow. To export it, click Publish to PowerPoint or Publish to PDF. Choose a file name, e.g. test. Open the presentation and enjoy the results. In future tutorials, we will teach you how to create professional templates for your FlowDoodle presentation. Thank you for using FlowDoodle. We hope this tutorial helped you get started designing your very own MEMS or semiconductor products.